At a football game, student tickets cost $3 each. Adult tickets cost $5 each. The school sold 700 tickets. They made a total of $3,078. How many adult tickets, how many student tickets were sold? So there's the two answers. So, the money is not being spent just on one thing, it's being spent over two things. So just making the XY table, drawing the line, that is not going to work. That's an input-output. Okay, this needs to be a system of equations, systems grid. So you have together, two things you're buying together are the student tickets and the adult tickets. Okay, now down the rows we've got how many units per unit and total. Now what total, what per unit? Well, that'd be dollars, okay? That's what's being spent on the two things, dollars, okay? All right, now, so your how many units? Fill that out first. It'd be 700, but that's together. So then these are the unknowns. So that's the answer to the problem too. You got x plus y equals 700. Now, jump down here and get your total. Slot it in, 3,078. So since we know the how many units together and the total together, this is worthless. Okay. There's another problem where it's not going to be, but it is today here. So $3 for the students and $5 for the adults. Then money total for students. Well, I don't know how many, but I know they cost $3 each. So x multiplied by 3 is 3x. Y multiplied by 5 is 5y. So these are my two equations, and I stack them, and that's why it's called a system, okay? I saw a couple people the other day subtracting the y and using substitution. I would not advise that. You could, but the elimination is way easier to keep organized as long as you're careful. So we're going to drop the x's out. We're going to multiply by 3 and by 1. So it's going to be 3x plus 3y. 3, don't keep it 700. You got to take your 700 times 3 just like the other terms. 2,100. Then on bottom you have 3x plus 5y and then 3,078. Okay, now you got to have that as a negative. If you want them to add to 0, you better be making those negative. So then we get our 0x, perfect. X is eliminated. Negative 2y. When you add those on a calculator, you best be making your 3,078 negative, or it's DOA, negative 978. Now we divide by negative 2, don't add 2 or something dumb like that, and that ends up as 489. So that's your y. Y is the adult tickets. So I now know that that's 489 adult. Now student tickets, well, I know that with the adult adds up to 700, so why don't we just subtract 700 minus 489 and get 211? Yeah. I mean, you can plug it in if you want, but you're kind of wasting time. Number 2, hardcover books cost $3.50 more than paperbacks. $198 was collected from selling 20 hardcover books and 12 paperback books. Find how much of each type of book costs. So we're going to find the cost of hardcover, cost of paperback. Alright, so again, the money is being spent on two different things as opposed to just one single unit. So we want to make the systems grid. You want to derive a system of equations. So together, or maybe it's just one equation. We'll see how it shakes out. You really got to read the problem, okay? You have to read, persevere, make sense. Okay, we're buying the hardcover and the paperback. So up here, that indicates how many units of each, including together, per unit, and total. Now, what's the dependent unit? It'd be the money. So money. Okay, up here, start filling this in. 20 and 12 both belong on top, and we actually know them. Unlike the last problem, we know the individual amounts. 20 hardcover, 12 paperback. So together, 20 and plus 12 is 32. Okay, now jump down here and fill out your money total. You can slot that in. The money total together is $198. Okay, now this won't be needed. Now don't put XY. That's not going to get you anywhere. You're ignoring a very important piece of information. The fact that this is $350 more than this. Hardcover is $350 more than paperback. So that means they're unknown, but we know that the hardcover is $350 more. So I put a plus 3.50 with hardcover. You got to do it with hardcover because that costs more. If it said paperback costs more, which would be ridiculous, I'd put it there. Okay, then this X, and I don't need Y. I don't want to see Y with that more than. I'm writing both the things I don't know in terms of X with that more than quantity. Now some of you are going to give me a coronary here if you don't parenthesize that and distribute correctly. I see people, they do the 20x, but then I've seen them put plus 3.50 without taking 20 times 350, which is how you distribute. I've also seen them add 20 and 350. No, you are distributing rainbows. That's times. 20 times 3.50 is 70. Then 12 times x is 12x. Okay, now you just have this equation. That isn't an equation. That's all you need. You don't need another equation, okay? Absolutely don't need that because you don't have a y. You just have to solve for x. So I add those and I get 32x plus 70 equals 198. Then I minus 70 to get to 128. Then I divide by 32, and I get 4. Problem's pretty much solved as long as you know where to look in the table. So X is 4. Great. The paperback's the cost per unit, $4. Hardcover. Well, X is still 4. 4 plus $3.50 is $7.50. Boom. Okay, number 3. Angie and Kenny play online video games. Angie buys one software package and 3 months of gameplay. She pays a total of $65. Kenny buys one software package and 2 months of gameplay. He's going to pay a total of $50. Find the cost of a single software package and the cost of a single month of gameplay. So again, money, but it's being spent on two different things. So the system's great. Don't make 2 of them. I know there's 2 people, but we can easily fit that into one and derive a system of equations from there. So we have together. And the 2 categories of things you're buying are the software packages and the months of gameplay. Okay, now, how many units? Going to need to know that. Going to need to know the per unit rate, and we're going to need to know the total. So these are the 2 independent units being purchased together. The dependent unit is the money. Money is always dependent on something, okay? It doesn't just come out of the air. Okay, up here, there are a lot of numbers that belong here. 1, 3, 1, 2. Okay, one software package, 3 months of gameplay. Those are together, so we need to put them across from each other. Don't go 1, 3, because it's one software package, 3 months of gameplay. Then we also have the second person buying one software package and 2 months of gameplay. So together, respectively, that's going to be 4 and 3. Okay, now there better be 2 totals for the money, and there is 65 and 50. So this will not be needed. All right, now we don't really know any other information, but these have to be 2 different variables. So x and y. I just put 2 of them because it'd be 1x and 1x, 3y and 2y. And there's your system right there. So 1x plus 2y equals 65, followed by 1x, or shoot, that's a 3y, I'm sorry, that's 3. I screwed that up. 3 times y is 3y, 2 times y is 2y. That would have been embarrassing if I would have got to that point. Okay. Why would I multiply? That would be stupid. I can just go negative this out, and the x's will come to 0. So a 3 and a negative 2 would make 1y, and then 15, because 50 is now negative. You don't really need to divide by 1. You know that y is 15. Again, sorry about that. That's a 3y and a 2y. I'd have been in trouble if I would have left that as 2y. Okay, so the months of gameplay, $15. Okay, how about the software package as well? We really can't just subtract, so we're going to have to plug it into one of my equations. I'll do the top. So 1x plus 3y equals 65. So I replace the y variable with 15. 3 times 15 is 45. So I subtract 45 to get 20. And then x equals 20. You really don't have to divide by 1. So $20 and $15. Okay, now, next problem. How many ounces of a 20% hydrochloric acid solution and a 70% hydrochloric acid solution need to be mixed to obtain 20 ounces of a 50% hydrochloric acid solution? So this is a percent. We're mixing a low concentration with a higher concentration. We end up with a concentration that's in between. Okay. So we're going to want our grid, but how I label it and how I go about filling it out is totally different than what I did on the first page. Okay. When you're mixing percent concentrations, you're going to have your low, then your high, then either put middle or in between. Okay, instead of that, be right in the middle, but it's in between. Now, down the row we go. We have our percent. You guys need to make your percent as decimals. Quit putting just the percents without expressing them in decimal form. Then, units. Well, the units are ounces. Then, don't put total. That's not this type of, it's product. Alright, low, 20%. You need to write that in decimal form. Now, I don't care if you write 0.20 or 0.2. I don't care. The decimal needs to be in the right place. So, high, 70%. Okay, so that would be 0.7. I personally do 0.70. Then the middle, 50%. And that'd be 0.50. 0.5, 0.50 is the same thing. I don't know why teachers dock you for having the 0. I've never understood that. It means the same thing. Okay. Units. Don't put the 20 down here. You don't jump down here. Okay. Totally different process. So for units, well, the ounces I have is 20. Okay. And that is the 50%. And these are unknown. X plus Y equals 20. Okay. Now, product, that means you multiply. So you don't, it's not 20x, it's 0.20x. 0.70y, and then I take 0.50 times 20, and that equals 10. Okay. So I think you see your two equations right there in a different place, but we derived the system. We know x plus y is equal to 20. We also know that 0.20x plus 0.70y equals 10. Okay, now you use elimination, so you're going to multiply the top by 0.20. 0.20, you can't lose sight of the decimal. Okay, so on top we get 0.20x plus 0.20y. You don't put 20, you take 0.20 times 20. 4. Now down below we have 0.20x plus 0.70y equals 10. Okay, let's negative this out so that the x's cancel. then you add these amounts, it's going to be negative 0.5. Now, I don't need any people screwing it up trying to do it in their head. 0.20 plus negative 0.70 is negative 0.5. 4 plus negative 10 is negative 6, and I divide each side by negative 0.5. 12. So how many halves go into 6? 12. Okay. Okay, so the high concentration, I need 20 or 12 ounces of the 70%. Then 20 minus 12 is 8. Okay. 8 at the 20. Next one's a quick one. Ratio of cats and dogs in the animal shelter is a 5-to-2 ratio. We have 63 animals available for adoption. How many of them are cats? How many of them are dogs? Okay, cats and dogs. Now, ratio, you set that up similar to the fraction box we were doing earlier this year. But instead of fraction actual, it's ratio actual. Now, ratio, you put a total, but you don't put this and not this, okay? You're going to put your cats and dogs in that order, the order they're listed. Don't put cats, not cats. That's not how a ratio works, okay? Now, 5-to-2. 5 is your cats, 2 is your dogs. You actually add these to find the bottom. See, on a fraction, if it's a fraction, you put the numerator here, the denominator here, and then subtract to find this. But the ratio is different, okay? 5, 2, 7 would be the total. Okay, 63 animals for adoption. Well, that's your total, okay? That's cats with the dogs. So 7 times what's 63? Well, it's 9, but if you don't know, divide 63 by 7. 9. 5 times 9 is 45. 2 times 9 is 18. So 45 cats, 18 dogs.